Okay, here we go. Hello. This is Nick, and today we're doing another create and hang. Doing something a little bit different this time. Essentially, I have a personal project that I've been working on at home. Actually, let me back up a little bit further. Either last week or the week before that, I had the idea to make a dungeon cam, which would basically a little tiny endoscope camera mounted to some sort of figurine to make it look like you were actually in a dungeon for Dungeons and Dragons. And I really like that concept. Problem is that right now, I do not have my area set up the way I want it for 3D printing, whether that's SLA or FDM. And I really want to print this in SLA because SLA does a lot finer detail. It's a lot easier to get tolerance points with it. And I generally find it's a lot easier to print minis on SLA because unless you're doing like sizable miniatures, really small stuff doesn't work, and I want this to be a little bit on the smaller side. So case in point, I have this workstation that I have set up, but it's not really configured properly. I've done SLA printing on and off throughout the previous year, give or take, and it's not really ideal is what I found. So I actually went through and reconfigured the whole area, which is in the back over that way. So it's in much better shape. However, I need to reconfigure the way that I am currently extracting fumes. I had this sort of weird setup. I don't know if I'm going to include it in this video or if I'll make it a bonus video or something so you can see what I'm talking about. But essentially, I need to improve the airflow. It works great, but it could be better. And I think we're going to basically take this time to 3D print a better, not a fume cover. The best way I can describe it is that I basically have an enclosed area that, and then the fumes want to suck I'm tired. It's been a long day. Basically, I need to have a section where I have the ability to close off the port so cold air doesn't come in when the fan is off. And I need to configure something so I can get the tubing there. In fact, why don't I actually just jump into GIMP here and explain this with some visuals, because obviously my ability to talk is not going along so well. So let me switch over in just a second. I think I forgot to update something real quick. Okay, sorry about that. I forgot to update my settings here. So let's go ahead and open up GIMP, and I'll give you some more detail about what I'm talking about. Also, I don't know why my webcam is so brightened all of a sudden. I've been getting a lot of driver issues with it lately, so bear with me. It shouldn't be too big of a deal for what we need to do, though. So let's create a new document. All right, let's create a drawing thingamabobber, doohickey, what have you. My brain is pretty tired right now, but we will persevere. I think it's persevere. So let's see, drawing. All right. Cool. So basically, I have this shelving unit here. All right. And there's a different level. So this section down here, this is FDM. Apologize, it's really hard to draw with just a mouse. Up here is SLA. And basically what I've got is this has been entirely sealed off with plastic. I mean, there's a flap here in the front that you can open up, so if I need to get in there. But the idea is that this whole chamber, and there's also a little pocket here to let fumes up from the FDM printers, is that air is going to come up from the bottom here. So basically, once the plastic is draped, it comes down over the front, leaving a sizable section for air to come in. It's going to come up through some holes in the bottom and then continue to vent up into... I have to carve a hole in here at the top. There's basically a piece of cardboard that's been sealed off with glue and tape. And I've got a hole here in the top that I essentially need to run some tubing out here, and then that's connected to a exhaust fan, and then so it goes up through the bottom, through the second level, up to this main level, up through the top here, and then out. Now I could just take the tubing and plop it and connect it right down on the top and just cut a hole in the cardboard up here. The problem is that I need something to close this when it's not in use, because otherwise the wind's gonna blow in, it's going to pull in dust and other elements and whatnot. And it's also, when it's winter, it's gonna be cold, and I don't want the cold air coming in. So that's something that I need to do. So we will close off this atrocity of a drawing. So basically what I need to do is, so let's say this is the top of the shelf is over here. Actually, we're gonna make this a lot larger just so it's easier to comprehend. Basically what I need to do is I need to create a system so that I have the ability to close it. And I think the way I'm gonna do that, I might actually do this in 3D. That might actually be a little bit easier to do in Blender. And then just for conception, because I know how to use Blender really well, and then we'll jump over to CAD stuff. So yes, I actually have a program over here called Freecad, which I was experimenting with, and I'll get into reasons why I'm using that. I know that typically Rob is the one who does the CAD tutorials with, I think it's Autodesk, not SketchUp, that's another program. Freecad? No, that's the one I'm using. What's the software? I gotta Google it. This is gonna bug me. Hold on. Hold on to your shorts. Autodesk Fusion is what it is. So I know he usually does the AutoCAD stuff, and I do not wish to impede upon that territory, so this should only be a brief set of live stream create and hang thingies to deal with. So I'll go back to my arena. But just for conception, all right, because this is probably going to be a little bit easier to do here. So scale this out on the... All right, so let's say, just for argument's sake, that this is the top of the shelf. All right. Why can I not? Why won't you do the shortcut now? Did I change the shortcut key? I think I changed the shortcut key. All right. Well, that is annoying. Is it up arrow now? Nope. All right. Fine. Be that way. I was helping a student out with Blender stuff, and I remapped my shortcut key to something. I am going to fix that because that is going to be very annoying. What am I looking for? Interface, navigation, key. Yes, here we are. 3D restore. Aha, there we are. Good. All right, so we got a thing here, right? And let's say, just for visualization, that's going to be our hole that we gotta punch into, which we can actually do a little Boolean operation here. Which Booleans in Blender aren't super fantastic like they are in CAD programs, but they do a decent job. So that would be cylinder. And then I should be able just to hide this. Yeah, all right, so I can cut a hole in the cardboard. That's no problem. However, what I need to do is have a gate to shut off the stuff, the air. And I'm just going to use the basic shapes here. Now, because of the way this is set up, because the shelf is actually pretty high up, I actually have to make sure that this gate, whatever it might be, is over here, near the front. And then this is just for visualization, so probably should move this up, huh? You know, and then obviously, you know, whatever this is basically something to slide in and out. And then basically this would be, let's grab this. All right, so it's a square, but imagine for a split second that is in fact a circle. So basically this bit over here, which maybe we'll actually make that a separate object. Hide you for a split second. Alright, we'll extend this out. Alright, yeah, so the idea here is that this goes in and out, cuts off the airflow. And then I want to have this centrally located because that's like where that's going to get the most area. So I'm probably going to have to either cut some tubing up and just extend it, Which, if we're being totally accurate here, let's... No, squeakers. Always bothering me when I gotta record something. I'm not doing another take because of you, cat. All right, so that will come in there. Do that. Let's just say, for argument's sake, scale Shift X. All right, there you go. It's a circle. Yay. So I could just 3D print this section and then maybe just have some tubing come over here. Maybe just reinforce it or something. That's probably going to be the fastest thing I could do in terms of getting this set up. Because I could also have... Oh, I don't need this anymore. Hide that. Because I sort of have a cardboard version of this right now, and it does okay, but it's like starting to fall apart. It's not 100%, you know, it doesn't, you know, stick together very well. So I'm debating whether or not I also want to, you know, also create a piece that essentially will go in here and then form a really tight fit, and then, you know, we can... I do have a lot of tubing, so I could do that. Or does it make sense to do this as one whole piece? I don't know. Let me model this out and kind of wrap my brain around this. I probably am still gonna have to print it in separate sections, even if I do want to do this. So let's just experiment. Hey, come on. Oh, what did I do here? I think I split it by accident. That's okay. And I know I'm probably not doing this extremely efficiently, but forgive me. This is just for visualization. All right, let's grab this bit, turn that on. You know, we can finagle with the height. We can do all that stuff. Because I'm thinking basically the less I need to print, one, I'm going to save material. Two, I'll save myself a lot of printing time. And it'll be a lot more flexible too. But this area is probably going to be a little bit of a problem. So I'm thinking... Because if I print at least this... I should be able to use that as a cutout, and I'll be able to seal it a lot better, rather than trying to, like, get the tubing into there. So maybe I won't make this quite as long. So maybe we'll actually take this off. You know, and then we'll have a... Nope. So maybe I'll just make that piece. You know, and then, of course, that will match up with... going down to that. Because then basically I can just have the tubing here and connect. And then that will continue on to the actual fan. So I think that can potentially work. Honestly, I'm actually just kind of curious to see if I can print it out as one whole piece. Just so I don't have to cut up. But again, I don't want to waste printing material because the tubing's a lot cheaper. So I'm thinking, and it's going to be less time and less prototyping. So let's do that for right now. I'll have to cut up the tubing I have, but I have a lot of it. So that's fine. The one thing that I'm going to have to make sure I do is if I do have the tubing here, because the air is going to be flowing out this way, I want to make sure that, I'm trying to think what would be the best. I think I want to have the tubing on the outside versus the inside here. Because if I do that, and the air's being drawn up this way, I'm probably going to lose some out through some tiny gaps here. So we probably want to make sure that this overlaps and all the air is drawn out that way. Because even then, it's going to suck in air through here if I can't get a perfect seal. And I want air coming in, not out. It's a very crucial point. So when we make these parts, I'm probably going to have to make sure that it is smaller than the actual diameter of the tubing. And I know the tubing is an 8-inch diameter, so we're going to have to take that account. I don't know how thick the tubing is, but it's pretty small. We should be able to stretch it if needed a little bit. All right, so I know which two parts I'm doing. One thing I can do, though, is I need to make this a little bit more stable. I could just, glue that to the bottom here and say heck with it, but let's also maybe put in some support pieces for this. I can always attach those later. So maybe let's say I could just add in like some basic triangles here to help stand this up. So let's come over to, what am I doing here? Let's go back to object mode. Let's add in, why am I still in the annotate? Get out of here. Let's see. Yeah. All right, here we go. And let's get this over here. Yeah, I'm thinking I can just make a 45-degree triangle here. And I can probably include some like little slots so they just slide together. That way I don't have to go too crazy with gluing. I'll probably still have to glue this to the top here just to secure it. But that's okay. So maybe I can just do one of these, maybe make it a little bit thinner. Again, this is just for visualization, but actually I'm going to delete this. I'm actually just going to create a plane, and let's just cut this, and we're going to delete half of it, rotate it. All right, there we go. So yeah, and I'll extrude this that away. So probably have to make it a little bit thinner, so it doesn't intervene with the pieces over here. I'm probably also gonna have to, again, if I want the tubing on the, so I said for here, and I want the tubing on the outside so that if there is a gap I can't get to, or if I don't seal it off 100%, it will still draw in air and come out. So for here, what do I want to do for this? I'm going to hide this for a second. So the question is, if I have air going out through, so I've got air coming through here, right? We've got little pockets here. That's okay. So if I have a thing coming out here and the tube goes around it, I'm still thinking that, well, air might actually slip out through this way. So in this case, do I want it on the inside? Does that make sense? So we've got a thing here, we've got a thing here, and then I got the tubing coming on the inside. Because then again, it's going to draw air that way if there's any gappage. Or do I want to just try and clamp it down and then seal it? Because that's otherwise going to be very loose. Because I can put a clamp doohickey around here. One of those tightening clamps, I forget what it's called. I think I still have a couple extra of those. And again, a lot of this is guesswork. I don't fully understand wind dynamics quite yet. But again, wouldn't wind follow the path of least resistance? At least that's what I'm thinking. Because, like, the problem with putting this on the inside is that there isn't really a good way to secure this. It's going to be very loose. So I do think I'm going to have to put that on the outside. Like, again, if I put this on the inside here, I would have to secure it with tape, and that's not great, you know, versus I can get a good tight seal if I put it on the outside. So I think we're going to do the same thing over here, even though my weird logic at whatever midnight o'clock it is right now is not holding up. So if any of you happen to be of the physics based nature, let me know you know, what you think, or if you worked on ventilation or anything. I'd be curious to hear like what the idea is behind that. Like, I don't know, I've never done this before. You know, my thought is that I want to pay attention to where the airflow is going, because it's going to follow that general path. So if we go here, obviously I can clamp this down, that'll be fine. But if I don't have this clamped on the outside here, that's not very secure. That's my only issue with that. So if I have something the vent can clamp onto, so this would be the outside, this would be the piping, that is not clear at all. So let's say that's like a side view of the pipe there. If I have the tube come over it and then clamp it down, it should stop that from going out. So air should... Again, I was kind of worried that I would have slippage out here, but if I secure it correctly, it should go out that way. Because, again, I could be thinking about this all wrong. Like, even if I don't do this correctly, because the air is being sucked in, there's a negative pressure, it should still come around this way, right? At least that's what I'm thinking. I guess it depends on where the fan is located. So I think we're okay still, because it's all going to be being pulled this way. Because there's negative pressure coming this way. It's going in that direction. So that's where my brain is right now. I don't know if that's 100% correct, but that's what I'm going to roll with. I hope that makes sense. Yeah, forget Creighton Hang. This is Nick's rambling at 11. No, is it? No, 12. Whatever the clock says it is over there. All right, so now that we've rambled our way through what we're going to be doing. So I've got support pieces here. Let me actually just duplicate this for a second. And we're going to make this its own object. If I could see where the P key is by selection. Oh, let's change where that origin point is. And, oh, come here. Maybe we'll give it some thickness so I can actually see what I'm doing. That would be good. All right, so we'll just make it partially straight. But the idea is that I'm going to have to give it a spot to clamp down on. And then, of course, we're going to have to put something on the outside here, too. Because I'm going to have to clamp it on in two spots on both sides here. Because this is all going to be filled in with tubing. We're going to have tubing going here. Clamp down, and then another clamp here, and then tubing, and then eventually to the fan. And then that will serve as the gate. I guess I'll have to design a wee handle there, but we'll get there. All right, so we're figuring it out. We're getting there. So now the question becomes, how do we 3D print this? This I'm not totally 100% worried about, because I can just put a little support material here And then I think that will... I may have to put a little bit on the inside, but this is such a large object, and once I get the outside clamped, I'm not too worried about, you know, drilling it out if I need to. So that, I think, is just totally fine. We don't have to worry about that. That we could probably print as one whole solid object. We'll just have to put some supports here and there. That's okay. I can, even if they're on the inside, if there's a couple like spurs, I'm probably not going to clean it just because it's not worth the effort. These guys, I think I can put little tracks on the inside here so they slide together. Because that way, then I can print these separately. So that will save some time. The problem is, how do I print this? Because there's a lot of overlapping stuff here. In fact, let's actually duplicate. That's fine by itself. I'm going to duplicate this. This whole... That's just the thing. We can... That's just the door. That doesn't matter. That we can come back to. Let me duplicate this nonsense. All right. So assuming we print these separately, which I think is a wise move, you know, turn that into explode view here. So basically, we've got a cylinder here, but we've got this gappage on the inside. Now, I definitely think this should be printed. Nope. In that direction. Because then it's going to have a flat side here. Just see here. Hide these. Granted, this isn't totally 100% accurate because I haven't modeled this correctly. Actually, probably should just for visualization add... I'll delete this whole thing. All right, so obviously there's going to have to be some faces on the inside here. Let's actually... But at least if I print it in this orientation, there shouldn't be... any supports. Well, that's not true. We're going to have to put supports here. Thing is, if I print it in any other orientation, so if I print it that way, we're going to have support material on all these pieces. That's way too much overhang here, which I don't know if we've talked about that kind of stuff, but basically, you can't just FDM print material midair. Same thing for SLA. You need to have something holding it up. So... if I have, say, printing a... why you do... If I'm printing, say, a diving board, all right, the printer can print this section no problem, but once it starts doing this path, the material is going to droop, so you're going to end up with some kind of fizzy thing down this way. Simply because melted plastic is not going to stay in the air for very long. You have to include some support pieces to hold it up. So... I'm thinking that's the best orientation for this. You know, we probably will have to put some support here. But again, because that's going to be on the inside, that should be all right. Yeah, there's going to be a little on the outside here, a little bit over there, depending on... Yeah, I don't think there's another way I can orient this, because if I flip it 90 degrees this way... then that's going to be overhang all the way up the wazoo over here. And if I orient it the other way this way, then that's going to be overhang all the way on the inside. So there's definitely going to be some interior cleanup for this, but I don't think there's another way to manufacture this unless I break it up into more parts. So the question here is it worth it to do that? Because... if I have to reassemble this whole thing, that may mean more printing time as well, but that may be worth it in the end. Like, for example, I'm having some thoughts here. Like, for example, if we just printed this one face, like if we have a, yeah. So let's say I've got a cut here, and then it's just inset a little bit. So that way, later, I can actually take the outer piece, which is this guy, and just plop it on, and then just get this whole section done, and then attach it to this piece, which will essentially just be, whatchamahooz, it's a, can't think. It'd basically be a side piece over here, where you, basically, I'm thinking about splitting this up into different parts that will later be connected together. So, like, have a front, a side, and a back. I don't think I'm going to be able to comprehend that until I actually model it all in CAD, which is what I'm planning to do. But I think we have a basic idea of how we're going to go about this. I like how I have not... I'm kind of taking time and material into account. You know, it's very tempting just to model everything and let the computer do it and worry about it later, but stuff costs money, so, you know, gotta be very careful about that. So I feel good about this piece. I feel good about the overall design. The question is just, how much do I want to split it up? And I think taking this off makes sense. I don't think it would be too bad to print this as is, because you'd probably get support material probably along... Hey, computer. You'd probably get material along this area, corresponding under here, and then the same thing on the other side, and maybe a little bit on the interior. But because this is going to be a larger piece, I'm not seeing that being too big of an issue. We'll have to check it out when we go into the slicer program. That's really going to tell us what's up. So I think we're going to model this piece first in CAD, or at least try to, and then we're going to go from there. So let me just kind of save this. Desktop. It's not really a Blender tutorial, but we're going to go ahead and put it in here for now. So we're going to call this exhaust port. Blender, or I'll just call it visualization, or I almost call it pre-visualization, but that's like that's a movie thing. Visualization. Okay, great. So I'm gonna keep that open on another window there. Do I really need this? No, that's just when I was explaining to you. I don't really need this. All right, now I have Freecad already open. I was doing some tinkering around with it. And you've probably seen this a lot in Rob's tutorials, but basically, the reason I'm modeling this in CAD versus Blender is that it is a completely different tool, and it's going to work a lot more for my purposes. You'll see this as we go through, but the really interesting thing about CAD software is that you can base things off of sketches. And if you need to go back and change things, it will be linked in such a way that you can make changes very rapidly. You can make constraints that will make things more geometric. Blender is a fantastic tool, and I absolutely love it. But when it comes down to fine-tuning and doing very precise things, or going back and making changes, like even Boolean operations will start to get bogged down really easily because it's not configured for that. CAD is. Now, I am using Freecad because I don't have anything against Autodesk Fusion, but you need to use it for non-commercial purposes. And I may have some project ideas down the line that I may want to end up selling. So I'm going to go through the pain and anguish of learning a new piece of software from the beginning, so that way I don't have to learn 2 CAD programs. And plus, it just shows you that this is another option, and you can use multiple tools to get the same result. So this is something that I tinkered around with just to kind of get used to it. We're going to go ahead and create a new project here. We're going to close all this. I'm going to just make sure this is going to go to the correct spot. And Freecad, just like it sounds, it is entirely free, which is pretty darn cool. You can just download it. You don't have to sign up for anything. Let's go. Nope, wrong spot. Wrong spot. Here we are. Blender, exhaust, no, blip, blip, exhaust port. And we'll call this exhaust. Cool. Oh, look at that. All right, so the first thing we need to do is we need to create a body. And a body is basically like the body that you're going to be working on. So we're going to do that first. And, oh, I thought we defined the axes that was on. Oh, there we go. We do it here. So I think what we're going to do is we're going to define this in the Z. Which one is it? ZX? Yes. Come on. Do your thing there. No? Oh, my music ran out again. I keep saying I'm going to find different music, but I never do. Someone recommend music to me that's royalty free and won't get me flagged on YouTube. Let me see here. Z and X plane. Yes, that's the one I want because I'm going to consider that the forward direction. Okay. So what we're going to do here is we're going to make a series of sketches. And from there, we're going to add on more sketches. We're going to extrapolate, do all these cool things, and make it good. Now, I probably should have decided ahead of time how we're going to make this work. And I'm also going to have to take into account tolerances. That's another thing. We'll go back and do that in a little bit. So, according to my Blender doohickey thing, we're just going to start out with a box. Just a simple box. I'm going to just draw a box here. And I'm going to right-click. Now, I think I want to constrain this to the bottom axis here. Or no, actually, I want this to go now the bottom. Now, for this, you know what? I am going to call GIMP up just to do some scribbles and walks. I do not have plans for this yet. I am kind of going off the cuff a little bit. Alright, so I know I have tubing, which is 8 inches. We're also going to have to convert it into millimeters because that's what this program works in. I think you can change it to inches somewhere, but I don't want to go crazy right now. 8 inches is here. So if I got me box shape, then I am at least going to need the 8 inches. And I probably want a little bit of extra room for the piece. So, thinking maybe add an inch on both sides just for safety. So then I'm going to need a 10-inch thingamabobber. Ah! Sorry. We're going to need a 10-inch cube here. So, we got to do some conversions here. I am horrible at the conversions, so we will have Google. What is the conversion? So let's see. It is millimeters to inches, or vice versa. So this is really weird because 1 millimeter is 0.0393701 inches. So we're gonna 10. So that's 254 millimeters. So we gotta define some shapes here. So we're gonna say this is 254. So you'll notice that these are all constraints up here, and by constraining certain items, you can then sort of let the computer fill in some of the gaps sometimes. So for example, because I'm telling this absolutely has to be 254 millimeters. If I grab this side here, I can no longer move this together, but I can still grab the bottom and move that up and down, which is pretty cool. However, this is a box, so I want this and this to be equal. Oh, is it? Nope. There we go. So basically, because I've made these two sides equal, I have 2 degrees of freedom. Where are you talking about? What are you talking about? Oh, I guess I can still move it. That's why. But now, because there we go. Let's move that up. Because these are now equal. This is entirely locked off. It's only moving around. So what I'm going to do here is to keep it from moving is we're going to constrain it a certain distance away from the center point. So if I know this is 254, it should be half the distance to either of these sides. So, mathematics, 254. Nope, that's not what I typed. 254 divided by 2. That's 127. So the distance from this point to... Oh, I need a point. Okay. All right, so how do we do that? Again, I'm still learning here. I'm going to preemptively skip over this song because I know it's going to get splishy splashy. There's some really weird splashy noises in that track that I'm not a huge fan of. So what am I doing here? I could go into construction mode here, and we've also got this bit. No, it only lets me do points. No. Oh, that's weird. Oh, I think I have to be out of the shape for that to work. Okay. Is that right? To external geometry. Well, this isn't geometry. Okay, so we don't have any geometry to use that with, so that makes sense. Okay, then. So let me see if I can... Can I go here to... No, there's no point. I can go here to here, but I need a midpoint. Can I divide this in half? Is there such an operation that would allow me to do this? Oh, maybe I can select more. Yeah, I know. Let's see. Sketch. Sketching tools. Select origin, symmetry clone, rectangular, B-spline tools. Create a conic in the sketch. Interesting, but not what I want. So let's do this. Let me go ahead and make this a parallel line. I will... How do I want to do this? I'm going to make this 127. So now I have a line that is exactly half. So in theory, I should be able to constrain this here. But I don't want this to be included in the geometry, so that's a bit of a problem. I wonder if I should just redraw this, because then at least I will be able to do that. But that seems silly. I should be able to split this in half. Can I just go boop? Is that a thing that allows me to do it? Nope. Maybe I can just delete this. Ah, okay. All right, hold on. All right, so let's get rid of this. And I need to join these things together. So let's actually just do this. Okay, here we go. Now, I have to make these points the same. I don't think they're quite connected yet. In fact, there might be a third. Yep, there's a third one. So we're actually just going to get rid of that point. We are going to select both of these, make them the same shared point. We're going to select both of these edges, make them totally straight. So now I can still do that, however. So let's make sure these are joined and that these are joined. Come on, you. Yep. Boop and a boop. Okay, awesome. So that point will basically still be floating around here. But now I can designate the length. So that was 127. Okay, awesome. I can still move this around. But now I can use this as a point, and my geometry is still going to be the same. So let's go ahead and go from... I want to go from here. No, stop it. Here. Nope. Here to here. Oh, what did I do? I think I selected the wrong one. That one. Here and here. And I want this one. Cool. Now can I still move this? I have 1 degree of freedom, which is this way. So now we're going to... Oh, I probably need to split this up over here. So... Boop, and a boop, and a boop, and a boop. And is this connected? Nope. Let's make this straight, and this straight. Cool. And then we're going to constrain... Where are you hiding from me? So from here to here, 127. I still have 2 degrees. Oh, okay. Oh, it's not doing the points. That's not good. I suppose I should designate if they are going to be parallel or not. So I guess this wouldn't... The distance thing doesn't really matter too much. But you know what I'm going to do? Let me designate that the distance from here to here, because that point's going to move around. So let's actually just designate this distance really quick, which is 127. Alright, so we basically have that constrained, which... Can I actually get rid of this? No, I need that. Let me just double check and make sure my math is correct. Yes, okay, great. Alright, cool. So now I just need to constrain this. So the distance from here to here... should be 120. No, I want the points. Give me the points. Here and here. And that. 127. Alright, yeah. So now we're slowly locking it in here. And, just gonna... My foot is falling asleep. Whoop, not 17, 27. There we go. So now it's all green. It means that it's been completely constrained. So basically what I've done is I've ensured that this is at the exact center of this object. So that way, if we need to model anything else, I will 100% ensure that we do not have any problems matching things up from the center point. All right, cool. So we've gotten that done. We can close this, and we're going to create a pad. Yowza. All right, cool. Again, oh, I didn't designate a thickness, did I? We're going to do 2 dimensions for this. So if you do 2 dimensions, basically, it's going to... let me actually show you the origin here. So if you do 2 dimensions, it's going to push it up in 1 dimension and down the other. So it just gives you options for how long you want to make it in one direction. So if I increase it or decrease it here, whatever you want to call it, it's only going to go up from the center point that distance. But I need to figure out how thick I want to make this. Do I have my calipers here? I don't want to go too crazy. So I feel like something reasonable would be 20 millimeters and then make the door like 10 millimeters. So 10 and 10 on both. So that works. Okay, great. So that's the formation of basically this piece here. Now what I'm going to have to do is create a hole on the inside. Keep in mind that the tubing I need is going to have to go around the outside of this so I can clamp it. So the very outer area should be less than 8 inches. Probably like just make it a little bit less by like, I don't know, maybe like 2 millimeters or something, just so I have enough room to make that work. Let me get my phone away from the spiky calipers. So, where does that leave us? Gimp, I need you. Alright, so we got that defined. So I'm going to have... Yeah, come on. Alright, tubing's going to go around this. It's 8 inches on the outside. And I want to take it in by 2 millimeters? Yeah. Let's go back to our conversion over here. So if I know that this thing is going to be 8 inches, and I want to take it off by 2 millimeters, so it's 203.2 for 8 inches minus the 2, so it gives me 201.2 millimeters. I think that's going to be more than a reasonable amount of error. Maybe it's too much. I think that'll be okay. I can always seal it up. And again, if my theory is correct, air's only going to get drawn in because it's going to be at the other side of the fan. So hopefully that theory is correct. But again, probably want to seal it up as best as I can, you know, just to create a better vacuum, because the more holes and pieces that you don't have sealed up, the less suction you're going to get. All right, so knowing that I know that now, we're going to hide this origin again. And we're going to... Well, do I want to punch a hole in it first? Yeah, how are we going to do this? So I already know the dimension that I'm going to make with that. Why don't I do this? Let's actually just designate the opening here. And I think I probably want to have a good 30 millimeters, maybe even 40 millimeters, to ensure that I have enough. So this is going to be 40 millimeters here, so I have enough room to get the tubing across. This is going to be that length going to the very outside, not the inner diameter. So we're going to come back over. I know I'm going back and forth a lot, but this is first time I'm doing CAD. Well, not the first time I'm doing CAD software. I did it like for a semester in college. Literally have not touched it since. So it's slowly coming back to me. Very vague. Vague? What's a vague? It's very vague. Sorry. Me no speak no good. Basically, we used a program called CATIA. And that program was interesting, shall we say. Alright. And alright, I guess I'll have to designate the point here. Where's the... Can I not designate the distance from here to an outer point? I can change the radius, apparently. Well, let's put a stop to that, shall we? Contain an arc or a circle. Let's constrain the diameter. All right, so the diameter of this. So this is going to be the outer part of the circle, not the inner part. This is going to be, what did I say, 201.3? Yeah, 0.2. All right, so we got that. But I can still move this around, so I have to constrain this in some way. That's the origin point right there. I should be able to constrain that to the origin point here. So I'll just select both of these and do that, yeah? Alrighty, now we're cooking. Actually, this does remind me of CATIA, because when you do the constraints properly, it's supposed to go green. Though we had a very... I didn't have this teaching assistant, but a student basically went up to somebody in the faculty. I think it was a teaching assistant, maybe a grad student, who... he asked for help on constraining an object, and all he said was you have to make it green. He didn't say how you went about it, where the constraints were located, why it worked. No explanations like, you have to make it green. So, well, we know that. How do we do that? And it's just really the same thing. It was just absolutely not helpful. To this day, I can still hear my buddy Tom just yelling in frustration. Okay, so we're done with this sketch. Are we, though? Are we, though? I may go back to that sketch because we need an inner diameter. Let me see. Let me draw another circle here. All right, now this one, we probably don't want to make it super thick, but I don't want it to crush when I tighten it down. So I'm thinking a 10 millimeter thickness is going to be pretty good. Again, we may have to redefine this, but we will see. In this case, normally I would print out smaller prototypes. The problem is that if I print something small, like a circle that big, then obviously it's going to be way more, it's going to be much stronger because the pressure is going to be, you know, like if I try like crushing a circle that's this big, that's going to be a little bit easier depending on the material, of course, than trying to crush like a plastic circle that's this big because there's more room to maneuver with it unless you increase the thickness. So I'm trying to account for that. All right, so we got that. I want this to be 10 millimeters thick, so subtracting 10 from this should give us 291. Yeah? My brain is not working correctly, so we're going to just rely on the calculator to be safe. I think I did it right. 291.2. All right. Where did that go? Oh, yeah, there. Okay, cool. Staring me right in the face. 191.2. Cool. And then we should be able to just, I'm going to do this one. Come on, come on. Listen, you. Eh. We're going to constrain this to here. Oh, I need the vertexes here and here. Boop. Okay. Now, can I loft these together? Is that a thing that will allow me to do such a thing? If I do that, and I do that. I don't know. This wasn't covered in the tutorial I saw. In all my experiments. I actually had to go through the wiki and read a lot of this stuff, which took a little bit of time. Create a pocket. I probably have to go over to, let's see here, surface. Fill boundary, create surface from 2. Okay, tool requires, oh, okay, so that's a no-go. Didn't like that. Design, because that's a pocket, that's a hole, sketch, loft. Oh, do I have to add section? No. Uh-oh. Oh no, don't crash. No. Oh. Well, I did something. All right, hold on. Let's just cancel this for a second. Let's save it because I haven't done that yet. Actually, I'm going to hide the body here because this is getting a little annoying. Error, but must be executed. Oh, it's part of the whole thing. So let's hide. We're going to hide this. Oh, it's no. We're going to hide that. We're going to work with this. All right. All right, you. Swear we're gonna work something out here. Sketch tools, groove, additive pipe, additive loft. Let's try an additive loft. Ah, dude. All right, it's doing something. Crunching away. Hope I didn't crash it. While it's doing that, there we go. While it's doing that, I'm gonna hop onto its wiki page and just see if I can find anything about. Okay. Oh, but it's reading it as the whole sketch. Do I have to create 2 separate sketches? So let's remove that. Cancel. Ugh. Huh. Okay. Supposed to be in the part? Utility to loft? Unknown territory here, folks. Create some. Oh, I gotta read a little bit more here. Well, you know what? It's almost coming up on the hour. Why don't I do a little bit more reading off screen? And when I come back, we will continue on with the adventures of building this exhaust fan. I realize not a lot happened in this episode, but I had to get my head on straight to figure out exactly what it was I was doing. So let me save it here. I'm going to read some more about lofting, because the general idea is that I want to create a solid shape out of this and then extrude that up and combine it together. We'll get there, though. We will get there. Thanks for joining me. I will see you next time. Let me know what you think, and you know, if you want to learn more about CAD stuff, you want to learn more about animation, which is usually what I do, you want to learn about modeling in general, or anything that is interested in the digital world, make sure you give us a buzz. You know, we are more than happy to sit down with you, talk about what you're looking for, and get you started. All the good things. My brain is no longer working. Thank you for joining me. I'm Nick, Director of Operations. Hope you have a fantastic day. Bye, guys.